So first of all, let's revisit our expectations, right? What we wanted here to what we wanted you to learn, and what we couldn't provide. Where we aimed at teaching at you the conceptual framework of Bayesian inference, and the two main points of Bayesian inference are: it assesses the probability of the hypothesis given the data, as opposed to the other way around, like in null hypothesis significance testing, and that we integrate prior information and continuously update our beliefs in plausible parameter values when we see and observe data. The next step was introducing you to wonderful BRMS and how to use it. And this was for some of you almost trivial because you're familiar with the syntax for the model per se, right? Because you used it in learnB4, for example. Even if you could not follow that part, we provided you with some materials to revisit the technical implementations later, and we highly recommend that, right? We also discussed priors, the big new unknown for most of us, and it became clear that this is the area that is, introduced the most question marks, right? In this class, we restricted ourselves to weakly informative priors, also called regularizing priors. These priors are just rough ballparks of possible plausible values. They do not bias model results, and I hope I demonstrated that at the beginning of the class today, but they help us fitting these models. And finally, we introduced ways to do inference with our posterior. We took a strong stance-ish against strict decision procedure. We emphasized gradual probabilistic inference. And if you do want a button press procedure, there are alternative approaches in Bayesian analysis, like, for example, Bayes factor or model comparison. They come with their own baggage and their own problems. So we didn't cover them here. And we have also, philosophical problems with this approach. For many of you, this might have been a frustrating experience. I acknowledge that. We could not give you an introduction to R, and we could not give you an introduction to linear models, both of which were relevant for applying these things that we told you immediately, right? For an efficient Bayesian workflow, you should know both of these things rather well. So if you feel shaky on these topics, again, we highly encourage you to brush up on your knowledge and then possibly revisit our materials. Given that we have discussed during the last 2 days, here's a summary of the Bayesian workflow, okay? First, before we even touch R, and that was a big one, we have to think very carefully about a lot of things. So our research question, our hypotheses, and the underlying quantitative system. When we apply Bayesian methods, we need to be a little bit more in touch with the data and its structure. And I hope this becomes clear. And this can be very scary, but I think this is a really good thing. Second, if we can, we specify the model that we find most appropriate for our data and our research question. We can try to figure out what kind of parameters the model needs to estimate using the get prior function, for example. And when thinking about the priors, we want to carefully think about plausible values for the parameters the model estimates. For example, are values larger than 1,000 hertz for human speech plausible for the difference between two speaking conditions? Probably not, right? You see, at this point, we need to be much more aware of what actually happens when we run a linear model. We need to understand the inner workings much better than might be the case for frequentist approaches. So the fourth step is actually specifying these priors for all parameters. We talked about this step extensively, but not enough, clearly. Our recommendation is to stick to weakly informative priors. Then in step 5, you actually run the model in BRMS with the priors you've specified in advance. And sometimes the sampling procedure might fail or result in a few divergences, but this is not as dramatic as it is for the learnB4 package. And we've just discussed common ways to fix these non-convergences by, for example, increasing the number of iterations per chain, or by specifying more appropriate priors, or other tricks that Joseph just mentioned. In step 7, before we dive into the model results, we want to make sure the model assumptions fit our data structure. We want to critically evaluate the model fit, for example, with the posterior predictive check function. It's a neat way to double check that we are in the right ballpark. If the model fit seems really off, we might want to reconsider refitting the model using a different link function, for example. And I showed you an example of that. But if we are happy with it, with the fit, we can go ahead and draw a probabilistic inference over the posterior probability. And instead of applying a thumbs up, thumbs down decision procedure, we argue for a more nuanced quantitative interpretation in light of the posterior, given the data, the model, and our prior assumptions, and to kind of relate it to our knowledge about the quantitative system under investigation, right? What is a meaningful difference, right? This is a simplified Bayesian workflow for starters, so to say. But this is quite a bit of new stuff for most of you. Here's what most of us have done before. We thought about it, formulated the model, and ran the model. And if it didn't converge, well, we changed it to something less useful and interpreted the results using a strict decision procedure, right? So a lot of things we added in these 2 days to this workflow. It's much more involved, for sure. And we would like to stress one more time that this workflow requires a lot more thinking and understanding of that underlying system. We need to think about the underlying generative model. That is how the data came to be. For example, for measurement that are bounded to 0, it is common that data are not fully normally distributed because variance can vary asymmetrically. This is true for many phonetic measurements. We talked about it. Here's an example of the articulation rate when we fit it with a Gaussian assumption versus articulation rate when fitted with a log normal distributed residual assumption, right? So there are differences between these. Here's another example. When modeling pitch, fundamental frequency, for example, we might make simplified assumptions about data generation process. You can see here that the data is bimodal. However, the model assumes that data were generated by a single Gaussian process. What are we missing then? Well, we are missing the fact that speakers self-identified with 2 different genders. Assuming that it largely corresponds with sex, the 2 groups will have different anatomies leading to different pitch levels, right? And taking the predicted gender into account, our model fit becomes much more similar to the data distribution that we see. But thinking is not only involved when defining priors and evaluating model fit and choosing likelihood functions. We need to carefully think when interpreting posteriors. Again, we explicitly try to avoid shortcuts, so there's no thumbs up, thumbs down decision procedure. Rather, we invite you to think about evidence as gradual and ideally anchored in our domain knowledge. And we have tons of domain knowledge about what we're looking at, about the quantitative system we are investigating. And this is super exciting for me because it makes us much more engaged with the data and our research question and what we're looking at, right? Speech. So we think this is an incredibly important tool or like set of toolbox that hopefully helps us accumulate knowledge and evidence in a much more nuanced and helpful way than a crude, black box, black or white decision procedure. And one of the huge advantages of BRMS is its versatility. I'm confident that 99% of our research questions here can be tackled with BRMS and Bayesian model. And I give you a little show reel of what it can do, right? The BRMS, this one package. We can obviously run mixed models, right? We just discussed that. We already touched on that. One example of work is I did with Dina Berheni, shout outs to Dina, on incomplete neutralization. And one interesting component of this is that we basically replicated a lab experiment in a classroom, and we were not interested anymore in evaluating whether incomplete neutralization is there or not, because it is, but whether the classroom experiments and the lab experiments actually yield comparable estimates. So again, using our posteriors and comparing them across studies, we were able to establish that, even in the classroom with much more noise, we could arrive at very similar probabilistic results, right? So that was really helpful. And the code for all of the examples now is publicly available, so you can check that out later. Another area that we have not been explicit about, but I know you guys are keen to learn about, everything that we talked about generalizes to generalized linear models, logistic regression, for example. You can run logistic regressions with dichotomous variables, and a cool example with beautiful plots, I'm in love, can be found in a recent paper by Joseph's students on conceptually cued categorical perception and L2 learners. Again, the data and the scripts are all publicly available for you to have a peek. Often, we actually collect ordinal data, like, for example, ratings on a Likert scale, right? With the cumulative linking function, we can estimate ordinal dependent variables rather straightforwardly. And here's an example from one of our papers from the lab at Northwestern of Jennifer Cole and Tim Ma. Right? And another similar situation is when we have categorical dependent variables. Right? So for example, if we have any kind of categorical response, multiple choice, for example, for these measurements, we would need a multinomial model, conveniently applied by specifying the categorical family in DRMS. And here's another example from work by Martin Shashkuti and myself on cross-linguistic patterns in morphology, right? Is your dependent variable a time series? Very relevant for us speech scientists. Are you interested in formants or in pitch trajectories, for example? You want to compare the nonlinear patterns of F0 contours. Some of you might be familiar with generalized additive models, GAMs, and BRMS can fit these nonlinear relationships as well, using very similar syntax to the commonly used GAMs that you might be familiar with. Here's an example of an eye tracking study that has been analyzed with nonlinear growth curve analyses by Mar 2018. We can also generate accumulated evidence across published findings with BRMS. Joseph has recently modeled the available published evidence on compromised categories using Bayesian meta-analysis tools. And meta-analyses become more and more relevant for us in our field as well, as the empirical robustness of single studies is more and more challenged, right? So we can estimate effects across different studies. BRMS allows us to do this. And now it becomes a little more wild, but I think super important, so-called mixture models. And in this case, the assumption is that the generative model is a mixture of distribution. For example, a mixture of Gaussian distributions. And Simon Rösig and colleagues from Cologne used a simple mixture model to predict the distribution of intonational properties across different focus categories. And as you can see here, model them as a bimodal distribution, right? It's really, really interesting work as well. And finally, and I think also super important for our field, multivariate models. We are used to estimate one measurement at a time. If we have more than one, well, we simply run several models, right? But actually, our measurements are often correlated and related to each other, and treating them independently means losing information about their correlation. With BRMS, you can estimate multiple measurements at the same time. And here's one example, modeling different muscles measured with surface electromyography, right? So again, open code, you can have a look at it. So that was a small show reel of all the cool things you can do with this one Swiss Army knife of an R package. It's really, really powerful. Let's quickly go through a couple of resources. We will add a lot on the webpage, and I think Stefan has already put a lot of them up. 2 Bayesian Bibles to push your understanding to Bayesian modeling. There is also, so basically there is the Kruschke doing Bayesian data analysis and has cute puppies on the front page. And there is the statistical rethinking book by Richard McElrath. And I have to say, that's my favorite stats book out there. It's fantastic. It's so well written. Kruschke is also a good book, but McElrath is so well written. It's fantastic. And there's also a digital translation into BRMS, because the McElrath book does not use BRMS, but there is someone who took the time to kind of translate the code and the examples into Tidyverse and BRMS, and it's available online for free. There's some resources that are not books. There are by now several helpful tutorial style papers for speech scientists. I find both Nabolt, I will butcher his name, unfortunately, Nalbortsuk et al. And Shravan-Bashish et al.'s tutorials, very helpful. Both come with open code, of course, and kind of tutorial-like our markdowns. And Michael Franke and I have also tried our best to write an accessible tutorial that actually uses a version of the politeness data set that we used here in this workshop. Might be useful for some, maybe not. If you have concrete questions, there's always the opportunity to ask in the forum, in forums such as the Stand forum or a Stack Exchange. And I obviously understand that these forums can be super intimidating because the questions need to satisfy a certain level of reproducibility. But it's a really good exercise to prepare a question for these forums. And people are generally really nice and helpful in both of these forums in my experience. So give it a try. And finally, we hope we have created an environment with our Slack channel in which people feel comfortable. And I've seen that already, asking questions and maybe helping each other. And I saw a lot of helpful, constructive interactions already, which is great. We are all working on the same overarching topic, right? And we can help each other grow individually as well as a community here. So this is hopefully kind of a community effort. And this is just the beginning, really just a springboard for learning, possibly learning these new tools.